All right, good morning. Can you see me and hear me? All right. You're going to get the worst presentation out of the way early in the week. So, I'm going to talk briefly about kind of an experiment we've been running, and I don't know how much time I have, but I'll try to go through it relatively quickly. And it's something we've been talking about for quite a bit. The last few years, people have been gaining interest. But my name is Matt Perlik. I'm with the Ohio Department of Transportation, and I'm going to talk about basically a stream erosion control technique we've been using that is pretty low tech. So we've heard about some pretty amazing technology this morning. This is pretty low tech, and it's something I want to kind of fill out with you. Maybe we get some other folks experimenting with it. I'm not an expert. I'm a user of this technique, and I'm learning, kind of relearning it with everybody. So the idea is that, oops, I just want to make mention about who I'm kind of standing on the shoulders of, and then we have a huge amount of people that have worked on this project and this concept so far, none less than George Palmiter, who kind of created this technique, which I'll talk about here in a minute, and a wide range of academic and professional consultants, staff, regulatory agencies, different ODOT, Ohio DOT district offices, and staff, along with drone pilots and others. So none of us is doing this by themselves, and I'm just kind of presenting a lot of information that is a collective work. And I also understand I'm keeping you between your lunch, so hopefully I will not hold you up. So just because it's an international conference, turned on Google Earth and was shocked to find that Ohio is not in the center of the Earth, but it's kind of located over here in that red blob. It's northeast United States. Some consider it the Midwest. It's a lovely place to raise a family, good cost of living, but not nearly as rugged or as interesting as Colorado. So George Palmiter, interesting guy. There's a lot of history behind him, and I'm actually trying to gather up some more information about him. But I realized if I let my hair grow, I would probably look a lot like this guy at this point, which is maybe a little creepy, like a dog owner that looks like their dog. Me being the dog and George being the owner. This guy was a railway brakeman who liked to duck hunt, and he saw the Army Corps of Engineers basically channelizing streams in the 70s throughout Ohio to improve efficiency. And he realized right away that this was not an effective way to manage streams from a stream health and from a duck hunting perspective, along with the ecology of the streams that he was moving through. There's some great backstories about him having to go to DC and explain his idea. And in the 90s, he was actually brought up in a book by the National Academies of Science that kind of compared him to Dave Rosgen. And so what's interesting is, we kind of turned into the Dave Rosgen natural stream channel design world, but these guys were both kind of in the same world of origin at the same time, which is kind of wild. And I've never heard of them until maybe just a few years ago. So really interesting history about this guy. I won't bore you with it too much, but the Army Corps back in the 80s, based on his visit to Congress and to Washington, started studying his idea. Miami University of Ohio did a report on him. There's somewhere on a VHS, a video of him doing his technique along with a training video. I haven't been able to find that yet, along with some how-tos. But basically, George was kind of verified, validated, validated. What's the word I'm looking for? He was validated by the Corps in the sense that, hey, this is not a bad idea. This technique he's developed on his own time to improve stream erosion issues might be a valid approach. And so this is the only thing I could find, and our researcher at Ohio University could find, that basically kind of documented the early work that he had done. And he did this work all over the country, North Carolina, Mississippi, Wisconsin, a lot of, I wouldn't say all over the country, but a lot of the Midwest and Southeast, and included a lot of, I would say, low gradient stream work, along with several projects in Ohio that nobody even can identify where they are anymore. So all of this, we were presented with this concept a few years ago. An executive management at ODOT came to my office and said, hey, investigate this technique. Let's see what it can do. It might be a low cost, high benefit approach to managing the countless number of erosion areas we have along our roadways. So as you know, kind of a traditional approach is dumping rock, maybe a retaining wall, maybe some type of head wall, extension, channel realignment. So pretty invasive, intensive work that includes hard infrastructure, gray infrastructure. And this technique provided a potential to maybe soften that a little bit. And so thus began our multi-year, oops, am I still sharing? Yes, okay. Thus began our multi-year investigation into this technique, and we're still going. So again, I'm not an expert. I'm just here as a lowly bureaucrat sharing my story. Hopefully, it'll gain some interest, and you all can also try it out in your localities. So, pretty basic idea, and it kind of goes against what I'll talk about in a minute here. That natural channel design idea, and that you basically use woody debris, not root wads, not root kickers, as I've seen kind of in the natural channel design area, but more or less a large amount of woody debris. I would call them engineered log jams to essentially create baffles or cribbing along the bank where the erosion is occurring. And so this is pretty high level diagram that I have here. Maybe try to understand a little bit, but basically just an aerial view. That was a joke. The aerial view of a stream showing basically the relocation of a bunch of woody debris in the erosion hole. And then I was stuck at an airport for a while, and I drew a color version. This would be an amazing presentation if we were back in 2001. You'd be blown away by these graphics. I'm sorry, but that's what you get today. So the idea is often we have log jams in Ohio and probably a lot of Midwestern states that basically totally realign a channel, which is totally fine and natural unless that realignment happens to then slam into your interstate or state route or other infrastructure. And so in this approach, a lot of times we come in and rock the daylights out of that channel to your right. We might build a retaining wall. We might do some channel realignment. We might excavate the log jam and excavate the gravel. Pretty intense, invasive type techniques, which potentially are okay, but in certain circumstances. But the Palmiter method essentially tries to let the river do the work. That was George Palmiter's kind of phrase. He wanted to do the bare minimum amount you needed to do to realign the channel naturally. So basically, the woody debris acts as cribbing. It catches sediment, rebuilds the bank where the erosion is, forces the channel to realign itself to the place away from your infrastructure. And in this case, kind of that gray bar down below would have been maybe a highway bridge that erosion area was approaching, and we've essentially stopped the erosion. So again, Palmiter is not natural channel design. I think that's something that we use, and a lot of you may be familiar with. It's very well engineered. It's very time tested. It's been around for quite a bit of time. Originated, I believe, by David Rosgen. And we do this type of work all the time, and it's pretty, again, extensive. It's intense, but it does result in a more natural setting. It's not just rock. It's not just a concrete channel. It's much better and much softer, much more nature-based solution. But Palmiter is not that. This is a channel realignment, again, to protect a bridge in an infrastructure environment, but it's not the Palmiter method. You might have some cross veins. You might have a J-hook. You might have some of these really creative, engineered, hard infrastructure, blended with, married to some softer infrastructure like root wads or plantings. The basic components of the Palmiter method are essentially woody debris, often gathered on site, anchored to the area of erosion, either tied to the ground or buried and attached to dead men in the bank, and then plantings along that bank and on top of that newly created bank. So again, the idea is looking at establishing a siltation cribbing naturally that collects silt as the channel naturally increases flows during high flows. The sediments will filter out and fall out of solution into those cribbing areas. So there's some benefits potentially. We're still learning about this, but there's some potential benefits in that typically we're not in the river with heavy equipment. We actually developed a regional general permit specific for this type of work to help streamline permitting and make it maybe a little bit easier to permit than say, the traditional hard infrastructure. It's going directly at the cause of erosion. It's trying to promote the work of the realignment of the channel being done by the channel. So again, siltation increasing in that area of woody debris and erosion increasing on the far bank where we want the channel to move. And we have some anecdotal data about a short-term increase in aquatic organism use and habitat of those areas. In fact, one of the sites I'll talk about, there's a little boy out on one of the logs that had been installed, and he just couldn't stop telling us about how awesome it was to now fish off of that log in the Palmiter area. And he was just catching snakes like crazy. He was super excited about it. All anecdotal. We also did a little bit of a bio assessments, but I'll talk about where we're going to go with that here in a minute. Hopefully you're not asleep. I can't see you, but there might not be any in this room. I have no idea. I'll just keep talking. So the key use cases for us are going to be realignment of a channel that's going to be eroding a roadway bank or coming at a bridge abutment. This is really common. We have streams, they move. We have about a meter of rain a year. We get quite a bit of flashy flows, and we have a ton of stream mileage across the state, and we have a ton of infrastructure. So, a ton of streams married with a ton of infrastructure. We have a lot of conditions where the stream is meandering away from where it was originally engineered to go through the opening, and now the engineered solution of the bridge or the roadway culvert doesn't move, but the stream does. We have to figure out a way to get those two to be married up again. So here's just a picture, from the guardrail looking down a erosion area that's moving behind the wing wall of a bridge or culvert. Slope failure, very, very, very common to be fixed with some dirt and some rock. Just falling, in this case, right into the waterway. And just a close-up of that again, just that same idea. We have thousands and thousands of these situations across the state. And so we're talking about maintenance and cost and putting workers out there. So again, it's a new technique that's been rediscovered essentially, and that we're trying to understand how we can apply it. And is it better to use this technique in certain circumstances? And some of the considerations we have to make are, do we need to get outside of a right of way? That would be a non-starter. Is there material on site that we can use? Do we have to bring in material? Are the environmental approvals going to be easier or less easy depending on what we're doing? And then, do we have the crew and the materials, the crew that's knowledgeable to use those materials in this way? It's not suitable for an emergency situation. This takes time. It has to have patience, but it is a good tool when you see those problems coming. And I have a little side story I'll tell you about that if I don't forget in a minute. But the immediate imminent failures, this isn't a good application. It needs time for that sedimentation and high flows to occur. The right of way may be a problem. We need to have material, and again, just reiterating that idea of we need to have time for it to fill in. So here's a quick example. One of the sites OU found, this is at a private property where the gentleman's standing. That used to be the middle of the channel, and so they installed a Palmiter erosion technique there on that bank, and over time, siltation, vegetation has reestablished that as the new bank. In fact, a nice low floodplain for that stream, and protected. In this case, behind us here, we're standing on a bridge, protected that bridge structure from further channel migration. Here's another just case study of a county road. It's just an aerial there on the left of what the stream was looking like. The farmer had removed the vegetation all along the bank, and so the stream was actively eroding down towards the road embankment rather than going through the bridge opening. And so there's a picture on the right there. You can see that excavator didn't cause that erosion. That's the start of them creating some dead men during construction. But you could see that their tile are exposed. There's clearly shelving off of the edge of the farm field, and that channel has been tried to be fixed with some rock. Fast forward, they installed the Palmiter method in this area, large amounts of woody debris pinned down to the ground and anchored to the shore. Here's an aerial image of that same area starting to be revegetated and starting to shift the channel north. Again, you can see there, even on the right picture, you can see some of the siltation and the plantings that come up. Sometimes when the trees are cut, they will stump sprout, and so you have instant new trees being planted in the floodplain just by the different species that you might use for your woody debris. So here's just a before and after, kind of where things are going. No more rock needed. The channel has been realigned and is being realigned into the opening of the bridge as designed. And it's slowly happening over time. There's not an immediate excavation of maybe mussel habitat or other species detrimental effects. But okay, so this is just cost comparisons initially with what had been done, with what could be done, and on average, it could be cheaper or about the same as rock. There's definitely some different variables that can come into play there, but it's just a quick hit there, and I can provide you the link to this report if you're all interested. So fast forward, our management says, okay, it sounds like you might like this idea. It might be valid for us. Let's go build one. And we picked a giant, complex, crazy stream to do it on. I guess we went big, and we may be suffering from that. But here we are in Ohio, we're like in southwestern Ohio, southwest of Columbus, kind of near Dayton, right? Patterson Air Force Base is just down the road. And Interstate 70, a major interstate across the country, is coming right through here. So back in, say, 2005, that red dot represents the southern bank. Now, 2020, 2020, I believe this photo was taken. You can see clearly the stream is meandering closer and closer. Stream flow is going north to south or top to bottom. The stream is coming towards our Interstate 70. So this is a site that it's a slow motion disaster. We can see the stream eroding towards the interstate. It's not an imminent failure. We have some time to act. So yeah, I don't think it's important, but we did do an additional repair to a dike upstream of this, but yeah, don't worry about that. Okay, so here's an aerial view circa 2022 of the erosion area. You can see a smidge of pavement up in the far top right. And what's interesting is you can see this log that's fallen and just kind of perched itself right there in the middle of the photo. I don't know if you can see my cursor or not. It's actually started to help create some aggradation behind it, just like I think George must have seen when he was out floating down the river shooting at ducks. That is interesting, right? Because it was starting to maybe recreate bank all on its own. So this is the site we picked. It's the Mad River. It's about 550 square mile drainage area in Clark County. And here's the pre-construction kind of just highly erosive, non-vegetated or mostly non-vegetated bank. We had quick plans developed by EnviroScience. We got the permits developed, and we got to work installing the woody debris, anchoring it. Here's immediately after construction. Here's this is 1 year after construction, and you can see just from the aerial, just comparing these two images. We've essentially used the woody debris as fill, and we got the Army Corps permits for that. And we even started to have a lot of stump sprouting from a lot of the trees we downed. So sycamores and maples started start stump sprouting right away. The goal is to essentially either halt or slowly shift the channel to the north in this location. Here is a picture just from a couple months ago where we've got continued increase of small debris piling up. It's not real good in this picture. So here's where we went sideways. Our engineers weren't comfortable with the concept. It's unproven. Nobody knows about it. And so we had to put a safety blanket behind it. So it's not the best test case, but so you can see back, we installed it, no rock behind the woody debris. We got nervous. We clammed up. We put rock behind it. So it's still functioning, but there's also the security layer behind it, which, okay, is good. Maybe you don't want to experiment with the interstate 120 feet away, but it's not a pure installation. But we do have some other areas north of that highly eroded area that we did use just the Palmiter method to try to redirect that flow to the west or the right in this picture. Here's just some examples of that stump sprouting right after installation. We can see some sedimentation close up starting to occur behind the woody debris. And then just this last February, they went back and added more material, some small woody debris amongst the larger items to essentially recreate that. And my PDF went blank. That's interesting. Can you see a PowerPoint now? Flying blind.
We still see your PowerPoint, Matt.
That was close to my last picture anyway. So I don't know what you can see now, but I'll just keep talking. I don't even know if there's anybody in the room. Maybe everybody's eating a turkey sandwich. I have no idea. Or the vegetarian option. So lessons learned so far. Start smaller than what we did. Highly recommend to start smaller than what we did. Pick a less dynamic stream. Maybe the name Mad River should have clued us into something. Ensure compliance on site. We actually had some trouble with some subcontractors not following our environmental commitments. We want to budget for more in-depth monitoring. So things like intense hydraulic modeling pre and post, along with mostly the post LiDAR modeling of what is actually happening to the stream. We did have it budgeted, but there's a long story and you don't want to hear it. But anyway, the point is, and also maintain as much on-bank vegetation as possible. And we definitely liked the George idea of minimizing the in-stream substrate disturbance to the maximum extent possible. We want to let the river do the work. Next steps, we have annual monitoring for that Mad River site. We have some additional tree planting and seeding happening this It's probably gonna happen in the fall now. And I'll probably be reporting out on this as asked by my boss and others through AASHTO and other channels. But more exciting to me, I think, is that we do have a brand new research project focusing on smaller streams. That's going to be a direct comparison between this method and the traditional erosion control methods like rock channel protection, things like that. So we're going to look at cost, time, infrastructure, risk, benefit, worker safety, and maybe more importantly, pre and post hydraulic modeling and biological indicators. Are we actually affecting the fish community, the macroinvertebrate communities in these areas when we do these techniques as compared to rock channel protection? Let's get some hard data to show one way or the other. And then are we able to achieve smoother, more streamlined environmental clearances for this type of thing versus kind of the hard infrastructure and maybe or reduce mitigation or no mitigation at all? So that's all I have to say. Appreciate your time. I wish I was there with you, and have yourself a great conference.
Questions?
So is this method improved mitigation for these federal highways or the state, or do you have to look at some of those considerations and consider that to help support that?
I did not hear any of that. Something about, was it for higher gradient streams? We haven't looked at higher gradient streams just yet. I'm making up words here. And let's see, another question I would ask myself that I can answer. Was it about mitigation, maybe? It's just one giant echo.
Hey, Matt, this is Dan. The question was, is it an approved technique by federal highways and by the state DOT? Does the Corps of Engineers approve of it? Can you give a little background on that part?
Yeah, so we're trying to make it an approved tool in the toolbox. And so this research is kind of all heading in that direction. We have been bringing the Army Corps of Engineers along with us on this journey to try to get them to understand what we're trying to accomplish. Initially, we had more rigorous permitting requirements on this work as compared to rock channel protection. And in fact, our latest RGP was going to have more rigorous requirements for this type of work as compared to a nationwide permit for hard infrastructure, which, we had some discussions about that. That really doesn't incentivize us much to do this type of thing. So we have brought them along. We have somewhat codified it in our regional general permit as a method. And so far, they really like the technique. Interesting side note is when you go out to these sites, it's chaotic. It does look more natural. And in some ways, I think the Army Corps of Engineers really kind of likes that clean rock look. The irony of that's wild, right? But the initial gut reaction is like, this looks like chaos and a mess, and it is, but it looks like a log jam. And kind of getting over that hump of they're just expecting this clean, pristine rock channel being thrown down there. So yeah, it's in progress, I would say.
Hey, Matt, can you hear me?
Yeah, I think so.
Oh, good. Interesting presentation. I think I look back the time I was working for the Washington State Department of Transportation, a lot of projects like this, as well as the 1990s, and very when we had river and mainland issues. What we found is the closer you got to the highway, the more you were a little bit harder fix, but by odd fix, further away with something that you're trying to be more proactive. And our philosophy was if it looked like hell, right? So that we could put everything in there. Are you seeing that and this is kind of an add on to the same question that was had before, are you seeing that biotic approach is something that the agencies that are managing the facilities are willing to take as you get closer and closer to their infrastructure?
Oh man, I think it cut in and out. Something about the managing the facilities. And what's interesting is, so the erosion problem at that Clark 70 site was not an issue that was on our hydraulic engineering office. when we walked down, I guess in this case, we walked up the river and looked back at the highway, they immediately saw the problem and they're like, oh man, this is a mess. This is going to be a big issue. And so what's interesting is a lot of us, we're so used to standing on the edge of pavement and looking at the pavement, or maybe looking 10 feet away from the pavement, and, you know, walking 100 feet upriver and looking back down totally changed their perspective. But it's not an approved process. It's not an approved technique. We are fully in the experimental realm, and, you know, thus the next level of investigation. But we do have our hydraulic engineering office engaged, and, you know, hoping to create some kind of standard out of the next research if that's validated. I made that all up out of like 7 words out of, I think what you provided is a very eloquent question. I only just got about 7 words, so apologize.
Hey, Matt, did you find that the agencies you work with, or landowner, manager, got more nervous? I guess the road owner got more nervous about using natural approaches the closer you got to that facility, or did they want to use rock as you got closer?
Yeah, I mean, this is a clear case where we did, and also just the experimental nature of it. Nobody was convinced, and there's not a lot of literature. But yeah, I think the beauty of this is you don't want to be too far out of the right of way where you're fixing somebody else's problem, but you also want to be, again, not an intimate failure that you can't really repair with this technique. It's kind of a sweet spot where a lot of our county managers drive by areas all the time where they see the issue coming and they can't manage it right now. They got other pressing things. And that's probably one of the biggest hindrances to implementation, is that it is a little bit of prevention rather than, you know, immediate response to a gushing wound kind of thing.